Hello, everyone. Thank you for being here. I know it's a bit late, so thank you for Reef to be here. Today, I'm here to talk about A2A and how you can create interoperable agents, so how you can make your agent communicate with each other. My name is Loïc. If you're wondering what are those two dots on the I, it's either in French to force the pronunciation of the I, or everywhere else to test UTF-8. That's basically it. I'm a senior developer for a Belgian consultancy company called Onirix. I have a big dog at home and I love dogs, and I'm also one of the co-organizers of the Belgian Java user group, so if you're in Belgium, please come say hi. You have my social if you want to connect, exchange, feel free. So why do we need something like A2A? Because first, an agent is just a simple service that's supposed to be able to accomplish something, have a goal. And to do that, it will use probably some tools, some resources, some context, everything that's available for him to complete the task. And when you have that, great, you have an agent. But until now, our agent just looked like this sheep, alone on an island. So basically, you have built an application, you have put an agent in it, and it's all alone, or you put other agents, but they're all in your application. Basically, you build a monolith for agents. And that's not very flexible, and you're really limited. It means that every time you need to develop a new agent to contact, I don't know, procurement or something like that, you need to redevelop it. That's not really how we try to do things usually. We want to reuse all those things. So it would be great if agents could chat with each other. And if you look at what we do with AI, we try to mimic what we do ourselves. And usually, when you try to build a house, you have a builder, you have a plumber, an electrician. You don't try to have one person doing everything. You try to have everybody to have some expert doing things. And that's what we try to do with agent to agents, to have different experts that we can call and use to accomplish some task, and so some part of the solution. So that's basically where A2A lands. A2A is a protocol that's originally been developed by Google and has been pushed into the Linux Foundation. It's supported by a major actor in the IT. So it's not just Google pushing its own protocol. And A2A stands for, of course, agent to agent. So communicate between two agents. And if we want to do that, we need a lot of things. And we need to define what the protocol can do and what we can use in there. And the good thing is, since it's been developed by Google and then everybody helps on that, they started with enterprise in mind, not just, my local development on my computer. So we started building this protocol on open web standards, so the things you know, such as HTTP, JSON RPC. They also use HTTP REST. So all those things are there in the protocol. Basically, they have three ways to work with A2A. You can use either JSON RPC, gRPC, or HTTP REST. They all are available, so it's a bit painful because not everybody going to use the same protocol. But at the same time, A2A is really young, so we are not really sure of what's the best solution, and they still try to figure this out. A big thing if we look at MCP is the beautiful S in MCP for security. Because with MCP, everybody had to figure out a solution to have some kind of security. With A2A, security is embedded in it. So basically, they try to look at what we do with OpenAPI. So when you use your API, your REST API, you have security. A2A has the same level as OpenAPI, so you have really the same kind of tools, some security in there, to allow to have agent-to-agent communication, but in a secure way. Not just anybody can come and grab your resource or do something you don't want with your agents. And then, when you look at MCP, there is two ways to work with MCP. Either just messages, but I would not recommend it. There is task. So basically, every agent needs to complete a task. And those tasks contain some messages. And a task doesn't mean I needed to do it right away, synchronously. I can definitely work asynchronously. So I can say, OK, can you do that? And just wait and let the agent do its work, and when it's done, notify you using webhook or things like that. It's really built to do whatever you want. You can do direct communication, where what you used to do with simple HTTP REST API, or you can redo long-lasting task and let the user, or the agent in this case, fill out the things. Do its work without knowing exactly how long it's going to take. You don't need to do pooling. The agent will be able to notify you when it's done. Of course, when you talk about LLMs and AI, we don't want to just do text. Text is great, but that's not enough. We usually express ourselves with more than text. Just look at this. That's pictures. That's not text. But out of the box, with A2A, there is support for multi-modality. So you can provide text, you can provide image, you can provide sound, you can provide video. Basically, the protocol allows you to provide any kind of input. After that, you need to figure out, does the LLM behind this protocol support it? Because if you provide video, it's only able to use text. That doesn't work. But the protocol allows you to do anything you want in terms of what you can send to it and what it can send back to you. And of course, because it's a protocol, but it's quite new, we try to make it extendable. So they know that out of the box, you might need something more. And they try to let you do that, so taking A2A as the protocol, as the base, and then put some extension. And you might say, OK, that's great in theory, but does anybody do that? And in fact, Google is already doing it. They created a protocol called AP2 to do payment through agent, and it's using as a base A2A. So it's already extended by this example. And you will probably see others, because A2A is a base, and you probably have different requirements when it comes to payment, comes to, I don't know, any specific job or task that's not totally covered by A2A, and you want to standardize it. So I'll give you some blocks of A2A, but how does it work? Because that's nice to know, to say it does everything that I just said, but if it's just in theory, doesn't interest anybody. So the first thing you need for A2A is an agent card. And you can think of an agent card just as a business card or a resume. It's something that will be exposed on /well.known/agent-card.json. And basically, it will give you, to anybody calling this, this agent card, the information about your agent, what it can do, how it can communicate. It can even give you example how you can use it, or you can prompt it. So it's really a way to say, you can discover what I can do and easily find out, OK, that agent is able to do that, that other one is able to do that. And it helps an LLM trying to contact all those things, or another agent trying to contact all those things, to figure out, OK, I need to call this one or this one. And then, as I said, it's using tasks to communicate. And as any good agile developer, you know task, and you know that you need to use a beautiful board and have status on the task and things like that. And basically, that's what A2A is able to do. So when you want to create a task and you have two agents, what will you do is your client, Neo on the right, will submit a task to the server. And when the server receives it and say, OK, I can handle it, it will switch the status of the task to submitted. OK, I've received the job. I will handle it now. When it's ready to handle this task, it will simply change the status of the task to working. And you can get live update on the client side if you want to. It will help you know, okay, my other agent is working on it or not, what's happening there. But at some point, the server agent might think, okay, it gave me a lot of information here, but there is something missing. For instance, you say, okay, can you book me a flight? And from, I don't know, Brussels to Vegas, but you don't give him a date. Using that status, saying, okay, there's an input required, will allow the server LLM, the server agent, to send a message to the client to say, hey, I need more information. Can you provide it? And how you can provide it? Again, whatever you want. And another thing, it's recreating a real collaboration between your two agents. It's not like I'm sending a request and call me back when it's done. It's I'm providing you a task. And if at some point you need more information from my side, please contact me. And we can really have this communication between those two agents, not just calling a server and hoping for an answer. So in this case, what we'll do the clients is just provide some information to help the server agent to go further in the task and keep working on it. And hopefully at some point it will complete the task. We all hope that's this is really what we want, that this agent complete its task. But it's nice, it's completed. How can I get some info from that? And to do that, there is some agent right now can just provide it through a message, but what I think is the most logical way to do it is to use the artifact. So you will provide an artifact, basically a deliverable from your server, to your client saying, here, your package with all I've done for you. And what's in this artifact is basically the answer, but it doesn't need to be just text. You can have text, you can have video, and you can have all those answers in different format in the same artifact. So an artifact has multiple parts, and you can have video, text, whatever you want in it to provide the answer you expect from the server agent. It allows really some flexibility on what you can get back from the work of an agent, because in the demo, usually we do something simple, but you can imagine that an agent is way more complex than that, and maybe it will do 3, 5, 10 things for you, and you need to have a way to get the result for all those things. But of course, we would like to, every time we use any software, that everything goes right. But we know from experience that it's not the case. From time to time, it goes wrong. And when it goes wrong, we need to have a way to handle that. And in the case of A2A, there is a status called failed. And when you have a status failed, it means, okay, I tried to do what you asked, but I couldn't do it. And basically, the server will notify the client saying, sorry, I couldn't do it. And from that on, the client can do whatever he wants. He can retry, you can imagine basically anything. But it allows really to say, okay, I failed, sorry. If you look at MCP, there is no standard for error right now. Here you have something, you have failed, and you can provide an artifact with the failure or a message with the failure. But there is other cases. You could try to submit a task. I'm not on the right side, sorry. So you have the server working on something, and at some point you say, oh, never mind, you don't need to do that, I figured it out. And you could simply send a message to say, please cancel this task, I don't need it anymore. And what will do the server when you send this message is just tag this task as canceled and not work on it anymore. It's a way to say, stop. The job is done, I don't care about the answer, please forget about it. Another thing is you could submit a task, and for some reason, the agent server is not available. He has too much to do, he has an issue, and in that case, the server is able to say, I'm sorry, I cannot handle that, I will reject your request, and send you an information saying, sorry, can't do that. Please come later or ask someone else, but I'm not able to do that. Another thing that you could have in those messages is, okay, I'm trying to do something, but I don't have the right privilege. Maybe I'm just using a simple user and I need to have a more privileged user. And what A2A is able to do is to set the status as authentication required and send the message to the client, say, hey, I'm sorry, I need more privilege to do that. Can you provide me information? And you can provide a GWT token or something else to say, okay, here is a credential, you can continue. But at the same time, if you say, I'm sorry, I don't have the access for that, it will just cancel the task for you. Because if you say, I don't have the privilege, I don't touch that. And there is a last status, and to be honest, I'm not sure about this one. I really feel like it's just the null of A2A protocol because there is a status unknown. And I'm pretty sure that if you have the status, you really feel just like the sheep wondering what's happening here, because what am I supposed to do with that? I'm not in my task. I don't know where it is. I don't know what can I do with that. So that's a bit of a special status. I already mentioned a couple of times MCP. And when you read at first A2A and MCP, you might think, why do I need A2A when there is MCP? What's the difference? Why should I use one? Are they there to do the same thing or not? And in reality, they are not at all just competitor. You can use both of them for different reasons. You've probably seen this illustration for Entropic that shows that MCP is a bit like the USB or for LLM or agents. Because what it allows you to do with MCP is a standard way to connect tools, resources, prompts. So basically a simple way to get some information from somewhere or to execute something. Really just like when you put your USB-C in your computer, you say, okay, it's doing that and I don't have to care about the protocol. And if you see MCP as the USB of the LLMs, you can simply see A2A as the Ethernet of the LLMs, because it allows a simple way to communicate and to connect to an agent using a simple connection, a simple protocol. That way they can communicate. For the older part of the audience, you remember when you could connect two computers together and finally communicate between those two? That's exactly the same thing. Here you can connect two agents together and more than that. So it's really a different solution than MCP. MCP is there to get tools and resource. A2A is just to connect agents. Can you just make a small applause for Dimitri here taking picture, because he takes amazing picture, please. So that's what we can do with A2A. But I really would like to show you a bit of a demo, because I'm talking for, I think, more than 20 minutes now, and I still didn't show you any code and how you can use it. So let's try to show that. So I have a small demo, and as you might guess, based on the picture, by the way, ChatGPT doesn't think it infringes any copyright. I don't know why. We will inspire ourselves from a few superheroes here. So I have three different agents. I have Iron Ram, of course. I have Bruce Banner. And I have the Bavenger, because, of course. I think you guessed it. There's a lot of sheep in my demos. So just to go through all that, I have here just my Iron Ram. It's just an AI service. I'm using Quarkus with LangChain4j. So I register the AI service. I provide a system message. I have a user message for a specific method that can collect objects. I've provided a few tools here. Because it's Iron Ram, he has Barvis as the AI assistant, of course. And all of that, I show you tools. But you can imagine that it can also be MCP tools here, because it would do the same thing. It will be looks really similar. And this agent, as I said, needs to provide an agent card. And this agent card, you can build it I'm going to do this so you have a bit more thing to see. You can create a simple agent card producer. And what you will do, basically, there is a few annotation, but you use a builder to create the agent card. You could write the JSON by hand, but there is a builder, so you can do it in your Java. It's maybe a bit more familiar for Java developer. So you will provide a name and a description for your agent. You will provide an URL where it can be called. You can also provide documentation, and I think we always forget about that. But if you provide an A2A service to someone, it would be great if he has some documentation to know what it can do, how it can, what's supported, whatever. Provide documentation, please. Then you will provide some capabilities. So that's where you're going to say, OK, I'm allowing streaming. I allow push notification to notify my client to say, OK, there is something there. You can look at it. I can also provide some history if I want. Here it's very simple, so I disable most of the thing, but you could go further than that. You can provide the default input mode. So basically, do I want to accept text, JSON, images, whatever? That's where you say it. And there is the output mode. It's quite obvious. That's the other way around to say, OK, you can get that from me, that type of information. Then the last part, and it's probably the most interesting part, is the skills. You will describe what your agent can do. By the way, I don't think that's really a great idea and name, but that was what came to mind when I wrote it the first time. Yeah. So I'll give a quick description, and something I think that's really interesting and should be there every time is the examples. Because that way you can say, OK, here's a few examples how you can prompt my agent. Because we all know that even if we call that prompt engineering, from time to time it really just feels like prompt tinkering. Because you're trying something and say, no, I don't have the right answer. I try again and again. There are some techniques, but at some point you really feel like I'm just changing a word and I have a better answer. Why? That's the thing. So you will provide all this information, and from that you just have the simple JSON that gives you information about your agent. The second thing you need is the executor. And right now, to be honest, all this agent-to-agent protocol is still a lot of boilerplate code. But I'm expecting LangChain 4j or Quarkus to make it way easier to use in the weeks and months to come. And basically, the agent executor, what's interesting in there is you're going to execute something. And if you look at it, you will see all the steps and all the states I told you about. You have a task updater. The first thing you look at is there a task? Yes or no? If there is not, I will submit it. So I create, say, OK, submitted now. Then I can start working. Simply say start work. We will go to the working state. Here there is a little bit of code just to extract some information. If you look at it, you will quickly understand that I'm just going through all the parts of the message I received to collect every text I have and put it in one string. That's a really naive approach, but for the demo, we don't need more. And then what I'm going to do is call my agent, so my Iron RAM, and say, please collect, providing the assignment and letting me do his work. And when it's done, I will just add the artifact to the updater, saying, here's the artifact. I provide all the parts I have. In this case, there is really only one, just the response. And then I say, the task is complete. That's done. I'm going to show you the same thing for my friend Bruce Banner, but there is a small difference. And I think it's interesting. So it's really the same. If I show you the agent card, it's really similar. But if you look here, you will see that when I execute my task, just right here, I try to snap, it might fail. If I miss an infinite stone, it might fail. And this method can throw an exception. And in that case, I can simply say, OK, I failed. Please provide the information to the client. So now the goal is to just execute all that. So I have a simple application here. I'm using the new agentic API from Lifechain4j. So it might look a bit different than usual, but it allows me to avoid all the creating a client with A2A. If you want to learn more about that, there was a talk earlier today from Guillaume Laforge and Emmanuel Bernard about MCP A2A, and they go way deeper into that. So if you want to learn more, go there. And what I'm doing is simply creating a sequence of agents, and I have Nick Woolley that will say, please do this mission. And I run around trying to collect the Infinity Stone, and finally Bruce trying to snap it. So let's hope for us that Bruce is able to do it. So if you look here, and I hidden my console here, I have some log here, and it's trying to collect something, and of course, because it's demo, it's totally failed. It didn't find the right items. But it will go through everything for me, and it's calling remotely on that. Oh, apparently he correctly found the thing, so I didn't look at the right thing. But basically what happened is every step went through, and now Bruce was able to snap, and I got the answer saying, okay, everything is fine, he accomplished his mission. So that's really a simple example of what you can do with A2A, and I think you will probably find better ideas than that in the coming days, I hope. But that's just to give you an idea. So back to the slides. A2A is really there just to enable collaboration between agents, to have all those agents chat, interact, and have real exchange between them, not just, I call you, you give me an answer. It's also completely complementary to MCP. As I said, MCP is there to provide you tools, resources, prompts. A2A is there to allow you to make two agents communicate with each other. So you can have an agent that's using MCP for a lot of things, communicate with A2A with another agent. And that's basically what you can do with that. And the last thing, and I think that's really important, A2A is really young. It's a couple months old, and to be honest, preparing this demo, I had to build some snapshot of Lifechain4j because at the time it wasn't really on the right version of A2A. So it's really young, so it will evolve, and probably we'll see some improvements and some more specifics on some tasks. But it's really, really young. But if we look at this, we already have a A2A SDK for Java. We can use it with Lifechain4j. So it's really young, but we can already play with it. So I would recommend trying to play with it. I'm almost out of time, and I would like to have a minute for questions. So I will end here. There is this link to the slide rest right here. I will put it also in the app. So if you want to find it in the app, feel free. I still see a couple of phones up, so I will let them take the picture. Yeah, looks like it's good. One thing I will ask for you is go to the app and please rate the talk, give me feedback. I would really, really appreciate it. There's the QR code. Again, you can scan it. You're already at the right place. So don't worry about searching for that. And before I leave you, I have a small gift for you. I have stickers done here. And if someone has a question, I will be happy to answer it in the minutes left I have. So feel free. Thank you. Any question? Yeah. I think right now, you can use it if you want to do kind of microservices of agents, kind of. But to be honest, it's really young, and I'm still trying to figure out. The usual example you will find is travel agent. I have an agent to look for my flight. I have an agent to look for my hotel and things like that. But that's kind of trivial. I think we are really early, and we don't really know where we can use it right now. Yeah, but that's basically the same question, why you don't build only monolith. Same question. And because you ask a question, you get a gift. We are out of time, so thank you again. You can come by and we'll answer that. Thank you again, and see you around.